Hello, in this video, we'll solve this particular problem. This is a calculus problem using the trapezoidal sum. Calculate the approximate area under the curve f of x equals to root of x plus 2 in the interval minus 1 to 11 using 4 sub-interval. Then the B part is to justify whether the answer is an overestimate or or underestimate. So this question, what is it saying? It's let's just have the diagram here. It's like this. So the function, it's just like this. This is the graph of root of x plus 2. And the interval here, this point is going to be minus 2. But we are interested in which interval? Minus 1 to 11. So minus 1 should be somewhere here. And this is 11. Okay. So we want to find the area under the curve of this graph. But we're asked to use what? We're asked to use 4 sub-intervals. And we know that the width is given by the formula b minus a over n. So what is b? B, this is a and this is b. So we'll have 11 minus 1 over 4, which is n. And this will give us 12 over 4, which is 3. So it means the width of each triangle is going to be 3. So we have, if this is 1, our starting point, we will have this. Then we'll add 2. So the next point will be 2. So you can see now the width here from minus 1 to 2 is a distance of 3. That is our delta x. Then if we add another 3 here, this will be 5. If you add another 3 here, this will be 8. Then if you add another 3, then finally we have 11. So this is what we mean by 4 sub-intervals. But this question wants us to use trapezoidal sum. So let's talk a little bit about trapezoid. When we talk of trapezoid is just a combination of, let's say, something like this. We can have this. So this is a trapezoid, or it could be in this way, this way. So now it's a combination of what? It's a combination of a rectangle and a triangle. For example, if we're using this one, let's say now this is going to be the triangle. So let's call this one our H. Now the distance from here to this point, let's call it what? Let's call it A. And the distance from here to here, let's call it B. So definitely, what does that mean? It means that this part from here to here is going to be B minus A, right? So if we want to find the area of this trapezoid, it's going to be the area of this rectangle. So it will be the area of the rectangle, then plus the area of the triangle, right? Okay, so what is the area of the rectangle? As you can see, if this is h, this is the height of the triangle, then this is also going to be h. So the area is going to be a times what? Times h, because a rectangle is what? Length times breadth. So it's going to be this h times this a. Then plus Now, this is a triangle, this the second part, and we know the area of a triangle is half base times height, yes? Okay. So, but what is the base? The base of this triangle is going to be what? It's just b. This is the base. The base is from here to here, which is the b minus a. So it's not going to be just b. It's just to be b minus a times height. So that is it. So that is the area here of this triangle, b minus a, because b minus a is the base of the triangle, and this h is the height. So we have this. Now, this one we can rewrite it as what? We can write it as 2ah over 2 plus half b minus ah. Okay? So if we take 2 out, we can take 2 out, 1 over 2 as a common factor. So what we have here is what's just going to be 2ah plus b minus what? A. And we can also take h out. Actually, we can take h out. So because h is common, so we can put h here. So this is what we have. So this becomes what? H over 2. 2a minus a is going to be a plus b. So finally, we can write it as half a plus b times what? Times height. So this is what? This is the formula for the area of a trapezoid. Now, let's come back home to answer this question. To answer this question now, if you look at this, all you need to do is to try to create a trapezoid from this question. So how do we do that? We're going to join these 2 points, this end point. So you can see, if you look carefully, you can see that we already have a trapezoid. Yeah, we have a trapezoid. You can see because you can draw a line here. So we'll have a trapezoid. Okay, let me use this blue instead. So you see the whole of this side down here and down here is one trapezoid, right? So we can still have another trapezoid. If I connect these 2 points, these two, you see, this also is a trapezoid because we can convert it into a rectangle and a what? And a triangle by drawing just a line here. Also here, you can convert this point and just draw line here, and also you can join these two. So now, but remember, we know that what if we want to find the area based on Riemann sum, we said it is the summation from I is equals to 1 to n f of xi. You can use xi delta x. This is the general formula for Riemann sum. Either you want to use the right hand, the left hand, the midpoint, or the trapezoidal. So we already know what is our delta x. We don't need to, our delta x, we already know is 3. So here, everything is 3. So this will be, 3 can come out as a 3. So you just have summation x is equals to I to n of what? Xi, f of xi. Okay, now, how do we get f of xi? That is the question. Remember, what does f of xi represent? F of xi is going to represent what? Is going to represent like what? Like the height. Or let me even just, let me keep it simple here so that you can see clearly. So now let's take this first one. Let's say we take this first trapezoidal. If I take this first trapezoidal, now let's compare it with what we have here. And remember, we said the formula is going to be a plus b times what? Times h. Look at h. What is the h? The h is this distance. So the h is here, from here to here, which is like the width But in all of them, the h are the same because this is h. This also is going to give you h. Then this is also going to give you another h. So it means using this formula, we will have for the first trapezoid, we're going to have using the formula half. Okay. Then we have now what is a? Look at a. A is the distance from here to here, from here to here. So in this case, our a is just going to be the distance from here to where? To this curve. So this is a. But the distance from here to this curve, it means you need to find what? You need to find f of what? Minus 1. That is what will give us a for the first trapezoid. Then what is b? B is just what? Is the distance from here to the top here. So it means B is just going to be the distance from here to where? To this point. So this is going to be our B. And what is that going to be that B? Is just going to be f of what? F of 2. So it means we have to add it plus what? F of 2. Okay? So this is half A plus B times what? H. So what is the h? Just like I told you, the h is the width here, which is 3, which is our delta. Okay. Now, this one is just for the what? Just for the first trapezoid. Then we have to do the same for all the trapezoids. So let me remove this one now. Then plus, now the second trapezoid is this one. It's just the same. It's just going to be half. Then what? In this case now, your A is going to be what? The distance from here to here. So which will just be f of 2 plus B is going to be f of 5 because B is now the distance from here to where? To the top here. So f of 5. Then the same times what? H. What is H? H is, in this case, is the what? Is the distance from here to here, which is our height. And that distance is the same thing as delta x, which is still what? 3. Okay. Then plus, now we are here, the same story. Here we have, in this case, is going to be half. So you have f of what? F of 5 now, plus f of 8. Now, the same thing times 3, plus, then finally, we are in the final one, which is just going to be half f of 8 plus what? F of 11, then times what? Times 3. So you see, each of this is the formula for the first trapezoid. This is the area for the second trapezoid. This is the area for the third trapezoid, and this is the fourth area. Okay, so what are we going to do? But to make it very easy, you can what? You see that you have something that is common. What is common? You see that this 3 is common, which is like our delta x. And also you see half is common. So you can take 3 over 2 actually outside as a common factor. So you just have f of minus 1 plus what? F of 2, then plus. Then here you have f of 2 plus what? F of 5, right? Okay, then you can have now plus. Here will just be what? F of 5 plus f of 8. Then here will be f of 8 plus what? F of 11. And you're done. Now, the next thing is just to what? Just to substitute our function. Substitute our function. And what? Don't forget, what is the function? The function is f of x is equals to root of what? X plus 2. Okay. Now, this one, even if you want to make, you don't want to make a lengthy calculation, you can see something here is happening here. This is 3 over 2. How many f of minus 1 do we have? We have only one f of minus 1. You see, f of 2 is how many? Twice of it. So it means this is going to be twice f of 2. F of 5, how many? 2 times plus twice f of 5. Then plus how many f of 8? Twice f of 8. Then finally you have f of what? 11. So you see, only the first and the last one appears 1. The remaining happen two times. So now you can substitute. What is f of minus 1? Just go to your function and put what? Put minus 1. If you put minus 1 here, you have root of what? Root of 1. So this will be 1 plus, here you have twice f of 2 will be 2. So this will be 2 times 2 plus 2 into f of 5 is going to give you root of 7 plus 2. F of 8 is going to give us root of what? Root of 10. Then finally f of 11, which is going to be root of what? Root of 13. Is that okay? So now the remaining, you just need to get a calculator and try to get an approximate value for all of this. Now, if you do this correctly, I think use a calculator, you should get approximately about 30.3297. So this is the approximate what? The approximate area using trapezoidal. So what is the, in summary, how do you use trapezoidal? It's very simple. All you need to do is, once you have your delta x, so let me just summarize it. If you have a is equals to summation f of xi dx, and you are going from I to n, this is always the same most of the times. Like in this case, it is 3, so you can just factor 3. So you just have 3 summation I from 1 f of xi, right, to n. So in this case, just become 3 brackets. Now, how do you work with this f of xi? This will now be what? The sum of the 2 points, the average. The average of where? So for example, now, this will just be, the first thing here should be f of x1 plus what? Or you can say f of x naught plus f of x1 divided by 2. That will be the first one. Then plus, for the second one is going to be f of x1 plus f of x what? 2 divided by 2. So you continue until you exhaust all the what? Your rectangles. So this will be 3 divided by 2. Then finally, it will be f of what? X3 plus f of x4 divided by what? Divided by 2. That's it. So this is just the formula that you need to use for trapezoidal method. And remember, what is x naught? Here we are considering this. Remember, we started from minus 1 and 5. No, say 5, 2, 5, 8, and what? 11. So this is what we mean by our x naught. This is x1, x2, x3, and what? And x4. Okay. All right. So then now let's answer the B part of this question. What is the B part? The B part asks us to what? Let's go back here. The B part asks us to justify whether it is an overestimate or an underestimate. And clearly you can see that this is an underestimate, because if you look at here, we tried, when we join this part together, we still have the curve. It's still above the what? The rectangle. So you see the curve is above the rectangle. I mean, not just the rectangle, I mean above the what, the trapezoid. So the red line is above all the what, the blue line. So this is an under. So the B part, we're going to say that what the answer, or what is the answer? The sum is what, or we say the trapezoidal sum is what is an underestimate. So you can give reason. You can say the curve is what is above the trapezoid. Now this is one statement, or you can just say because your what, your function is what, is concave up, no, concave down. Yeah. So anytime you have a function that is concave down means something like this. In that case, your trapezoidal sum will be what? Will be underestimate, because all the trapezoid will be below the curve, right? Okay, now this is what we mean by concave what? Concave down functions. But if you have the function to be concave up, for example, something like this, then the trapezoidal sum will be what? Will be overestimate. So take note of these two, because in that case, your trapezoidal will be below some part of the curve. Some will be up. Why? For example, if you have, let's say you have this, if you have something like this, and you want to measure like this, you have this. So if you want a trapezoidal, you need to go from where? You need to go this way, right? See, you need to go this way. So you see some part of the trapezoid will be above the what? Will be above the curve. So like all these parts are above the curve. So it will be an overestimate. All right. So I hope this explanation is clear. Thank you for watching.